Hello and welcome to my channel. Continuing solving some examples about finding the shear force diagram and the bending moment diagram. We will solve in this video one of the examples that needs two cuts. All of the previous examples we solved, we did only one cut in the beam. So here we need to make two cuts. So the loading is as follows. We have moment here of 80 kilonewton meter, and the point load in the mid of the beam 15 kilonewton, and another distributed load of 5 kilonewton per meter. And this is point B, this is point A, and this is 5 meter. Okay, as usual, step 1, calculate support action. So we have this is the beam. We have moment here 80 kilonewton meter, 15 kilonewton. Fy at B, Fy at A, Fx at T. Summation force x direction equals 0, Fx at A equals 0, summation Fy equals 0, then Fy A, Fy B, and then minus 15 minus 25, the equivalent point load for the given distributed load, and this will be equal to 0, and the point of action of this should be here in the mid point of the distributed load. So this will be 25 kilonewton, okay, and in the midpoint, so this will be 7.5. okay, and then here it will be Fy at A plus Fy at B equals 4, and then summation moment at around Z equals 0. Let's take the summation moment about point A. Okay, so we have at point A we have the 80, and this is negative, and we have the negative 15 kilonewton times 5, the 15 kilonewton times 5 meter, okay, and this is negative as well. And then we have negative the 25, the concentrated load equivalent to the distributed load, 25 times 7.5, okay, and we have positive Fyb times 10. This should be equal to 0. So the Fy at point B will be solving this should give you 34.25. And going back to substitute in the Fy equation, then the Fy at A would be 5.75. Okay. Okay, step 2. Get the shear force and bending moment functions. And this is a little bit longer than the previous examples because we need to make 2 cuts in this beam. So we have, this is the beam, and we have moment right here, 80 kilonewton meter. We have this as 15 kilonewton, distributed load of 5 kilonewton per meter. We have 2 support reaction here at A. It's 5.75, 34.25. Okay, so in this case we need to do 2 cuts. Here will be cut 1, and here will be cut 2. Okay, and as usual we are measuring X from this side, so let's do cut 1 for X between 0 to 5. Okay, so this will be 5.75, 80 kilonewton meter, right? And this is X, shear V, moment M, and then solve summation Fy equals 0. That means 5.75 minus shear, this will be 0. So V equals 5.75, and then summation moment equals 0, and as usual we are taking the moment about the cut point, so M, and then we have negative 5.75x, and we have negative 80. This will be equal 0, so M equals 5.75x plus 80. This is for the first cut. And then cut 2 for X between 10 to 5. The beam look like this. we have here the 5.75. We have the moment 80 kilonewton dot meter, and we have the point load here was 15 kilonewton and distributed load of 5 kilonewton per meter, and we have the shear V and moment M. Okay. Okay, so let's do the summation. Fy equals 0. So we have the 5.75 minus 15 minus the 5, the distributed load, this is x, right? So this distance is x minus 5. So the distributed load would be equivalent to a point load of 5 times x minus 5. And it is acting right here at a distance of x minus 5 over 2. Okay, so going back to the summation Fy equals 0. So we have the 5.75 upward, and we have the negative 15 downward, and we have the 5 times x minus 5 is downward as well, and we have the shear is downward, negative, and this will equal to 0. Sorry for the space is not enough. So V equals 5x so negative 5x, and we have here 25 minus 15 plus, so this will be positive 15.75. Okay, this is the shear, and then let's get the moment. And as usual, we are taking the moment right here, so the moment, and then we have negative 80, this one, and we have negative 5.75x, the moment from this force. And then we have two positive moments, one from the 15, positive 15 times this distance, which is x minus 5, and then positive 5 x minus 5 times this distance, which is x minus 5 over 2. So I will make it this square over 2, and this will equal to 0. By simplifying this, you will find that the moment equals negative 5 over 2 x squared plus 15.75 x plus 92.5 0.5. Okay, and all of these two equations are valid for x between 5 to 10. So while plotting or drawing the shear force diagram and minimum diagram in the third step, draw shear force and bending moment diagrams. So this is the beam. I'll make it longer a little bit. Beam support. Oh, sorry, and that was the beam support, and then this is just to make sure I have the right. Okay, so that was a roller support. Oh, okay. We don't have an FXE because this is a roller support. Oops. Okay. We have FXB, not A. That's fine. This will not change anything. Just B instead of A. Okay. Okay, so go back to step 3. So this is a roller support and this is a pin support, and we have the 80 kilonewton meter. In the midpoint we have the 15 kilonewton. We have the 5 kilonewton per meter. Okay, and then let's do vertical lines, one for shear and one for the moment. This is for shear, V, positive, negative, and this is for the moment, M, positive, negative. Okay. Okay, let's get the equations for shear and moment. Remember that the equations that we will use for x between 0 to 5, this is 5 and this is 5. So the equations that we will use for the left part is different than the equations that we will use in the right part. So between 0 to 5, the V equals 5.75 and moment is equal 5.75x plus 80. So these should be the equations here. So the V here is 5.75, moment is 5.75 5.75x plus 80. Sorry, I should use red color. Okay, so the shear is a fixed value of 5, let's say this much, this is 5.75, and the moment for x equals 0 equals 80. Let's say this is 80, so I'm using red. This is 80, and for x equal 5 it will be 108.75, and it is linear. It is an equation of a straight line. Okay. The second part, the moment equation is a little bit more complicated. So let me write it down here. M is equal to negative 5 over 2 x squared plus 15.75 x plus 92.5. And for the shear, it was negative 5x plus 15.75. Okay, so for the shear, in case of x equals 5, so this will give you negative about 9. Oops. 9.75, or sorry, 9.25. And you have a linear equation, and for x equals 10, so you have negative 50 plus 15.75. This will give you 34.25, somewhere here, and it is a straight line equation. This is 34.25, negative for sure. Okay, and for the moment equation, for x equals 5, substitute here by x equals 5, this will give you the same number, 108.75. And for x equal 10, the moment will give you 0, and it has a parabolic equation, x squared with negative, so it will look like this. Okay, so this is a shear force diagram and bending moment diagram for this beam. I hope this video was helpful.